Okay, so yesterday we took our test. Some of us are finishing or starting and finishing today. Right. Now, we are starting 8.1. We gotta move forward. 8.1 is talking about rational graphs. So our warm-up is just to graph one and sketch it and get a little table. So can you graph 1 divided by x? Let's try it. Ready? New document, don't save, go to graph. How do I get a fraction bar? Control, divide, right? Control, divide, 1 on top. Wow. 1 on top, go down. X. Wow. 1 over x is, hold on, there. Looks like this. Now you see those two curves? That's the rational graphs. Let's go ahead and graph that. Now, this is very important. This graph gets really close to the x-axis. It gets really close to the y-axis on both sides. But guess what it doesn't do? It doesn't do what? It doesn't do what? It doesn't do what? Oh. It does not subscribe to Spectrum Mobile, and it's definitely not Michael Jackson. It is MC Hammer. Oh, sorry.
You know what? Like this for dad, this for dad. Just stop. You cannot dance.
All right. You cannot touch this axis. All right. So, hey, you cannot touch the asymptote. That's what it's called. You cannot touch the asymptote. The asymptote. 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 You cannot touch the horizontal or the vertical asymptote. You cannot touch the horizontal asymptote. Okay. Any other questions or requests? I'm trying to say the word. All right, here we go. Control T, get a table. And let's go and fill this in. 1, 1, 2, 0.5, 3, 0.333. How did I get it? I typed 1 divided by x. Yeah, Control T for the table.
That's what I was asking.
Oh, okay, yeah. Control T gives you the table for sure. Just remember, there's 2 lines you can't touch. Hammer time. All right, let's do these notes. Notes time. Oh! Stop. Notes time.
Sizing your crazy dad jokes.
Yeah.
Just stop. Just stop. I already know what you're gonna say. I'm gonna put it right there. I do. I'd rather be in Colorado.
I've actually never been to Colorado.
Oh, well, you should only rep what you've been to, you know?
I do. I'm wearing my Bumblebee every single day from now on.
What's that not happen?
Me? I have it in my house. Or my coffee.
That's right.
What happened to Lee TV? I haven't seen none of them.
So your Lee time teacher should be showing
He
all
wasn't there.
Lee TV. Never? See, that's why no one knows about I'm Second, because no one gets to see the commercials.
Oh, no. Oh, we
Well,
know.
no,
We know.
no, I know you know because you're in here and I'm here,
We know. We see you around the school.
and I do that. I spam the walls and I spam Lee TV, but people don't show Lee TV. So
All those posters are you?
no,
Ugly people?
Damn.
Yeah, that's him.
no,
Yeah,
On the right.
I am not the guy on the left, and I'm not the lady on the right. All right. So let's get to some notes. Here we go. All right. Rational graphs. Ready? rational graph gives you what we had on our warm-up, and the name of it is this right here. It's a hyperbola.
That sounds like a word.
Hyperbola gives you a rational graph, 1 over x, okay? Now, as you noticed on the warm-up, there's 2 parts of it. We call each of those parts branches. So you got the top right branch, you got the bottom left branch. Those are your branches. Okay, now again, we're doing these notes because when you get to the 8.1 assignment, you're going to need to know this stuff. So I hope you're not just copying, but you're listening, engaging your brain here. The domain is always left to right, correct? So do you see how this should go forever to the left? It should go forever to the right, but it does not touch right here, right? MC Hammer said so. You can't touch the asymptote right here at 0. So guess what? You're going to put that R. It is all real numbers, but it's not 0. Okay? So basically, it's everywhere except 0. That's where the dashed line is going to be, right? What about the range? Up and down. It goes up forever, it goes down forever, but it does not touch the, how do you say it?
Asymptote.
Not asymptote, okay? By the way,
Asymptote.
the P is silent, like in pterodactyl. I don't know if y'all even know that there's a P in pterodactyl, but asymptote, right? Okay, now, how do you get the equation of the asymptote line? So the horizontal, does everyone see? Horizontal, okay, goes through
No. The X.
well, the other math teacher that made this. So real quick, horizontal. Let's correct these notes. Ready?
Yes.
Horizontal goes side to side, right?
Yeah.
What axis does it touch?
Why?
The y-axis.
Yeah.
So horizontal should be y equals 0. Let's scratch this out. If you wrote that down, you know, it is what it is. No, you're not. It's just, it was not right on there. And then the vertical goes through an x-axis, so it's x equals 0. Cool. Now here's the deal. You can see it doesn't touch x, it doesn't touch y, so there's no intercepts on this one, but there will be when we do the examples on the back. Before we get to the back, look at the bottom. The horizontal asymptote is y equals 0 up there. All right. Vertical is x equals. So check it out. Everyone look. This is our form of our equation, right? Okay. So look right here. Look. And then if you're taking a test, I don't want you on your phones. Okay. Everybody, here's our form of our equation. A is on top. And A tells you 2 things. If it reflects or if it vertically stretches or compresses. Okay? This is standard stuff we've done for every function. The A value tells you if it flips or if it stretches. Right? Now, here's the weird part. Remember insider's lie? The insider thing is now on the bottom. Okay? So now that the liar is down here, okay, next to X. And then the K is normal, right? So the H is horizontal, it's a lie. The K is not a liar, it's vertical, right? Now, once you know H and K, vertical asymptote is X equals that number down here. That's a lie. And the K is Y equals the K value over here. Whenever you're doing 8.1, in the future, if you're doing any type of transformations for this is the information you need at the bottom of the front side. Cool. We're going to apply this on the back. Flip it over. Let's look at example 1. All right. So what's graphed here is the parent function, the OG original. So let's look at this. On top, I have a 3. First of all, is that negative? Not negative, so it does not reflect. But since 3 is greater than 1, that's called a vertical what? Does everyone know? Greater than 1, vertical stretch, right? So let's write this down. Vertical stretch.
Do we have to write that into a fraction?
These are all going to have fractions because x is on the bottom for rationals. So since 3 is on top, it's a vertical stretch by 3, right? Now, the next thing we got to look at is this number next to x. This is my new insider. So this is my insider. We know insiders do what? This thing's a lie. So instead of -4, what's that going to be? It's really a +4. So which direction does that shift? Okay.
Upside down.
To the right, 4. Okay. Again, I'm telling y'all, the number on the bottom is horizontal and it's a lie. So -4 really means to the right 4. Okay. What about the +2 afterwards? Which way does that shift to? Up 2. Okay. Oops. And then you can graph this. Now, if you were to graph this in your calculator and press Control T, you could get these points. Okay? So, everyone knows how to type this in, press Control T, plot some points. Go ahead and sketch this for me. I'll give you a minute. Everyone's sketching on the right. That graph, that new graph, right? So go ahead and graph. See a lot of non-graphs. I want you to graph on your paper that blue one up here. Okay. That graph. Nope. Not necessarily on the calculator, but you can. I just want to make sure it's on your paper. This graph is on your paper. So you can see that it moved 4 to the right, up 2, and it's stretched by 3. 1, 2, 3. 1, 2, 3. That's the stretch. 3, 3.
This, I don't even know.
Did you put the dashed lines at 4?
I did not put dashed lines, no.
Well, that'd be good.
Can I just put a solid number? Do they have to be dashed?
Okay, so let's do this. The next two questions, VA and HA. Do y'all know what those stands for? Okay, so here it is. VA is vertical asymptote. HA is horizontal asymptote. Okay. Now I'm going to make this as easy as I can for you, right? Vertical up and down goes through this axis. What axis goes like this? X or Y?
Horizontal.
X. So for my vertical asymptote, I'm going to put X equals. For my horizontal, okay, horizontal goes side to side. It goes through the vertical axis, which is the Y axis. So horizontal, HA is going to be Y equals. Now, guess what I'm going to put next to these equations? The vertical asymptote, since it moves right 4, guess what I'm going to put right here? 4. The number on the bottom, remember this is a lie. So this turns into a positive 4. That's where your vertical asymptote is, okay? So X equals 4. Cool. and then y equals the y value, which is 2. Yeah. Cool. So how do you graph it? Check it out. You might want to start with these lines. So draw a dashed line at 4, up and down. Up and down, yeah. And then a horizontal line at 2, side to side. And then if you plot these 2 points, you can just make a curve through them. Plot these 2 points, do a curve through them.
Domain, we can just put that R, right?
Yeah. Right. You see nothing?
No, it's Andy's. You asked that yesterday. You asked that. Maybe Professor. And then I said, okay, we found yours. I did. Then we got out of my bag.
How do you do that? I'm not going to do that.
Oh my God.
Put it there.
So check it out. Since it's stretching by 3, you're going to go over 1, up 3, 1, 3, 1. All right. Okay, now domain and range. Ready? The domain goes forever both ways. Hey, the range goes forever both ways, except it does not touch the line. So the domain is going to be everywhere except for this 4. So here's what you're going to write. Put the little weird R, all real numbers, but then you got to put x is not equal to 4. Slash that equal sign. Okay, so again, it goes forever left, forever right. It just cannot touch that asymptote. What about the range? Range is also all real numbers, but it cannot touch right here at 2. Okay? So all real numbers except not 2. Okay? Okay, so let me back up. This is not that hard if you realize, look where I'm pointing. This is a lie, so this positive 4 is going to tell you which way it moves, where's the asymptote, and where the domain is not. You see how that 1, 4 gives you 3 different things. Okay, this plus 2 tells you which way it's moving up or down, where's the horizontal asymptote, where does the range not touch. That number, bam, bam, bam. Okay?
The hardest part is graphing.
The hardest part could be graphing, but you can graph in your calculator, Control-T, plot some points, make a graph. But let's try example 2 to see if we can make it a little easier for graphing. Here we go. Example 2. Now, what is in front of this 5? Negative. Negative. What does negative do to a graph? Reflects across the x-axis. And then 5 is bigger than 1, so it's a vertical stretch. So we have a reflection over the x-axis. We have a vertical stretch. Right. All right. Then, what about the horizontal shift? Where does this, on the bottom, plus 2 is a lie, so which way does that go? Left 2, and this minus 3 goes which way? Down 3. Insiders lie horizontally, outsiders are vertical, no lie. All right? See if you can get the vertical and the horizontal asymptotes. Look at the one above that we just did.
I'll say.
All right. So what y'all get for vertical? Vertical is always what? What letter?
Y.
No.
X.
Vertical goes through the x-axis, so it's x equals, and x equals, look at the bottom next to the x.
2.
Except it's a lie, so it's
2.
so
Negative 2.
x equals negative 2. So x equals negative 2 because this is a lie. It goes right there. Doesn't that make sense? Left 2, negative 2. Yeah. What about the horizontal asymptote? What do I always put there? Horizontal goes through the y, so y equals, what's the y value? Over here, -3 is your horizontal asymptote. So over here, and you actually need to graph this like you didn't do on one. Okay, x equals -2, right here. Can you make a dashed line right there real quick? Up and down. And then y equals -3, put a horizontal line here at -3. That way you can graph that bad boy. Now, I want to see if you notice this. Normally, the graphs are top right and bottom left. You see how now they're top left, bottom right? They're not. Put them away. Put away. The situation that it's in your hands. So, now, here's the deal. We got to stretch it by 5. Do you see how from the, where the asymptotes cross, it goes up 5, over 5, up 5, over 5. Okay? That's how you tell what the stretch is. Of course, you could also graph it in your calculator, press Control-T, and get some points to graph. Okay? So make sure you graph the whole shebang. Plot these 2 points, make a curve. Plot these 2 points, make a curve. Now, what about domain? Domain is our x values. It goes forever to the left and forever to the right. Stop, put away. But it doesn't touch what? -2. Do not, put away. Okay, so again, it goes forever left, forever right, but it does not touch -2, so you're going to put all real numbers, x not equal to -2. You're going to have to do this on 8.1 assignment, so you better be paying attention. All right, so what about range? What does it not touch for the range? The horizontal asymptote, it cannot touch at -3. So you're going to put all real numbers, but x not equal to -3. Does everyone see that? This is a lie. That tells you this, this, and this. This over here, that tells you this, this, and this. If you follow that pattern, you'll be all right. Okay, you get to use your notes. So, does everyone have the graph and all this filled out? So we can try example 3, which is get the graph real quick, and then we'll do example 3. So you can get the vertical asymptote at -2, up and down at -2, and then horizontally at -3. And then plot those points. Make a curve. Example 3. There we go. Now, does everyone see there is no equation? But we have the graph. So can we work backwards?
No.
Yes. So here's my question. Actually, I'm going to write it up at the top. The standard form of this kind of function looks like this. Y equals a on top, x minus h on the bottom, plus k. First, let's figure out a. So everyone's listening. This is how you figure out what your a is. So, see this point? How far is that away from the asymptote?
6.
6. That means it's been stretched vertically by 6. And since it's going up and not down, it has not been reflected. So that's just a positive 6. Okay? So when I write this down, my a value is going to be a 6 up here. Which way did it shift? What's my h value going to be?
2,
No.
3,
This is a horizontal shift.
5.
Okay.
I guess I'm the only one trying.
At this moment in time. Everybody else, okay? We're talking about the horizontal shift. Just remember, this is a lie. So Colin said something close, but insiders lie. So horizontally, I see right here is a negative 3, right? But if insiders lie, what am I going to put there? A positive 3.
I said that this one, I said that number.
Oh, maybe you did. Well, maybe you didn't. Now, what about vertically? What's my k value going to be?
2.
Negative 2. Okay. Do you see how to figure out h and k? Just remember, h is a lie, and the stretch, letter A, is counting up from the axis. Okay. So my equation is going to look like this. Okay. Vertical stretch by 6 means I put a 6 on top. Shifting to the left 3 means I put a plus 3 on the bottom. Down 2 means I put a minus 2 afterwards. Okay. Okay. Vertical asymptote. We've done this 2 times already. If I see that it moves left 3, what do I put right here for vertical asymptote? Okay, negative 3, but what goes in front of the negative 3? Vertical is x equals, and then you put negative 3. Okay. What about? Okay, but what do I put in front of negative 2? Y equals negative 2. Okay. Remember, vertical and horizontal lines have equations, right? So domain, if it special R, but it doesn't touch negative 3, so how do I write that?
Comma,
X
that
not equal,
that has a line through it.
not equal to
Negative 3.
negative 3.
Ha ha ha.
So again, the vertical asymptote is where the domain does not touch. Similar with the range, it's all real numbers, but it's where the y is not equal to negative 2. Okay. Now that is enough. That's enough examples and enough information to try practice. Okay. You don't have just today, you also have tomorrow, so you don't have to rush, but you also don't want to waste time because a lot of us have missing things we need to work on too. So let's work on this and get it done.